For this project, the focus will be on creating an end-to-end real-time analytics streaming solution with Azure Databricks and Event Hubs. In terms of the environment setup for this project, you'll need an Azure account and subscription, an Azure Databricks workspace with Unity Catalog enabled, and Power BI desktop. However, the Power BI element is only a small part of the overall project. You'll also need to create an Azure Event Hub service, which I'll walk you through step by step, so you don't need to have that ready as we'll be creating it together. So at the very minimum, please ensure you already have the Unity Catalog enabled Databricks workspace available. So looking at the project from a high level, we want to process data generated by streaming sources that gets ingested into Azure Event Hubs, and then make this data available in our Databricks Lakehouse. For the final part of the project, we then want to create a near real-time report on Power BI using this data. The acceptable latency from Event Hubs to it being processed and stored in our Databricks Lakehouse can be up to a few minutes. The latency from it then being refreshed and updated on the Power BI report can be up to 20 minutes. So let me explain the solution that we'll be developing. Let's start with Azure Event Hubs. Azure Event Hubs is a large-scale event processing service that's part of the Azure ecosystem. It's specifically designed to ingest and process massive amounts of event data generated by applications, devices, or any telemetry producing systems. It can work with various data sources, including sensors from IoT devices, application logs, social media feeds, and more. Azure Event Hubs provides a feature which allows you to generate test data directly within the Event Hub service. We can use this feature to simplify the process of simulating event data for demonstration purposes. We'll generate some fake weather data in JSON format, and the format will look like what you see on the screen now. We'll process this data on the Databricks engineering platform using Spark structured streaming. We'll store the data on a Unity Catalog-backed data lakehouse using the Medallion Architecture. This architecture is named after its three-tiered structure, which includes the bronze, silver, and gold layers. Each layer represents a stage in the data processing and refinement workflow. Here's a breakdown of each layer. The bronze layer is the initial landing zone for raw data. Data in this layer is kept in its original form, typically unprocessed or minimally processed. We then have the silver layer. In this layer, data from the bronze layer is cleaned, processed, and transformed into a more consumable format. Finally, we have the gold layer. This is the highest level of the architecture, where data is further refined and aggregated. Data in this layer is often used for reporting, dashboards, and analytics. Now for the final part of the project, we'll make the data from our lakehouse available in Power BI via direct query, and we'll create a simple report. This part isn't really about Power BI reporting, but more to show you the capabilities of streaming near real-time data in Power BI using Databricks. Great. So that's the overall requirements and solution architecture for the project. Next, I'll give an in-depth overview of Azure Event Hubs. But before that, just a word of warning. For this demo, we'll be streaming data using Spark structured streaming. The streams will run indefinitely unless you actively stop the stream. If you keep the streams running, your Databricks clusters will not auto-terminate. So please make sure you're careful by terminating your streams and manually shutting down your cluster when you've finished. Let's now get into a bit more of a deep dive on Azure Event Hubs. As I've said, Azure Event Hubs is a big data streaming platform and event ingestion service. It can receive and process millions of events per second, making it ideal for scenarios involving telemetry, distributed data streaming, and real-time analytics. It's designed to handle high-throughput, event-driven architectures. Users can scale up or down based on the required throughput. Let's discuss the key components of Event Hubs. We have event producers. These are any entities that send data to Event Hubs. They can range from server applications to IoT devices. We also have the Event Hub itself. This is where the data streams are sent. Throughput units dictate the capacity of the Event Hub, determining the amount of data in megabytes per second that can be ingested and retrieved. A single throughput unit lets you ingress up to 1 megabyte per second or 1000 events per second, whichever comes first. And it also lets you egress up to 2 megabytes per second or 4096 events per second, again, whichever comes first. We also have partitions. Event Hubs uses partitions to segment data for scalability and parallel processing. It organizes sequences of events sent to an Event Hub into one or more partitions. As newer events arrive, they're added to the end of this sequence. We also have Event Hubs namespace. This is a container for one or more Event Hubs. It serves as a unit of scoping and billing. A namespace can contain multiple Event Hubs. And finally, we have consumer groups and receivers. They enable multiple consuming applications, each to have a separate view of that event stream, processing the stream independently. Okay, so that's enough theory. Let's jump into Azure Portal and create our Event Hub service. So on Azure Portal, let me search for Event Hubs. And here it is. So click on Create. And on the wizard, under Basics, select your resource group. This is the one I'll be using. Now give your namespace a name. I'll just call it EH-namespace-demo. Now for the location, I will select West Europe because this region is close to me and it matches the same region as the resource group and Databricks workspace that I'm using. For the pricing tier, I will choose the basic tier because this is the cheapest option and it's appropriate for the purposes of this demo. To get additional information about each plan, you can click here on Browse the available plans and their features. So as you can see, in the basic plan, you're only allowed one consumer group and message retention is 1 day. This means that Event Hubs only stores information for a single day. You also don't have this capture capability, which is available on Standard and Premium. The capture ability allows you to automatically capture the streaming data in Event Hubs and save it to an Azure Blob storage or Azure Data Lake storage for processing and analytics. But for the purposes of this demo, none of that is needed, so I will select Basic. And notice for throughput units, we can go from 1 to 40. But again, for the purposes of this demo, I will keep it to the lowest amount. You can go ahead to Advanced, Networking, Tags, and then just Review and Create. So once the validation is complete, I'll click on Create. So now let's wait for the deployment to finish. Okay, so the deployment is complete. So let's go to the resource. So we have accessed the namespace. Within the namespace, we can create an Event Hub by scrolling down on the side here and under Entities, clicking on Event Hub. So here we can create an Event Hub by clicking here. So let's give our Event Hub a name. I will call it EH-demo. EH for Event Hubs. Notice for the partitions, we can go as low as 2 and as high as 32 on the basic tier. And the retention time in hours is set to 1 by default. But we can make this up to 24. I will leave it as 1 because that's sufficient for this demo. If I go to capture, we don't have that capability allowed on the basic tier. So I'll review and create. Okay, so we've created our Event Hub. Let me click into it. For this demo, we'll be generating fake data using this feature on the side called Generate Data Preview. So let me click into it. What we can do is generate fake data in different formats. So you have text plain, XML, JSON, and binary. So we will put data in JSON format and just submit it to see what happens. So we've got some sample data here. Let me actually paste in my own data. So this is a JSON object. It's basically the equivalent of a single record in a table. We have curly braces at the start and the end, and that encompasses key value pairs. So you have a key, a colon, and a value. And key value pairs are separated by commas. So this is a key value pair, this is a key value pair, and so on. So this is like a column in a table, and this is like the value in that table. So temperature would be a column, and 20 would be a single data point or value stored in that column. So if this data was in tabular form, it would look like what you see on the screen now. Okay, so let me send the event by clicking send. So as you can see, the event has been sent, and it will be retained for 1 hour. Notice the structure. The message itself is sent in this tabular form. You've got message body. This contains the JSON object that we sent, as you can see. And then you've got other columns, such as the offset, sequence number, partition ID, enqueued time. So these are all metadata columns. So enqueued time would be the time that the message was sent to the hub. For the purposes of this demo, we'll only need the message body and the enqueued time columns for further processing. So let me go back to generate data, and now I will change this 20 to 30 and send it. So now as you can see, here is the latest event with the temperature of 30, and you can see the time that I sent it, approximately 1 minute after. Now on the resource overview page for this Event Hubs instance, you can see various metrics. So here's a spike from when I sent the messages and the requests. So here's the request, and here's the message. Okay, so now that we've created the Event Hub service, we'll create a connection to it on the Databricks platform and start to process it. Okay, so I'm in my Databricks workspace. It's in the same resource group in the Event Hub service that I've created. For this demo, I'll create a compute cluster and install the Azure Event Hubs connector for Databricks library on that cluster. This is the library that will allow us to create the connection to Azure Event Hubs. So let me go to compute, and then I will create an all-purpose compute. So click on Create Compute. For the policy, I'll keep it as unrestricted. And for this demo, we only need a single node cluster. I will keep the access mode as single user. And for the Databricks runtime version, I am actually going to select 12.2 LTS. This is because the library that I'm going to install, specifically the Azure Event Hubs connector for Databricks, supports runtime 12.2 at the time of this recording, but it does not support later versions yet. So the safest option is to install 12.2 LTS. I'll keep the node type as standard DS3 v2, and I will change my auto termination from 120 to 10 minutes of inactivity. Make sure in the summary that Unity Catalog is supported. So as you can see, this compute cluster supports Unity Catalog. So now let's click on Create Compute. So while the compute is being created, on the cluster, go on Libraries. So back in Compute, click on the cluster, and then go on Libraries. We need to install an Event Hubs for Spark Maven library on this cluster. So click on Install New, and then select Maven. So you can either paste in the coordinates, or you can search specific packages. I'm going to search for the specific package. So change the option on the dropdown from Spark Packages to Maven Central. And then in the search bar, type Event Hubs single word, -Spark. So you should see here, Azure Event Hubs Spark underscore 2.12. This matches our Databricks runtime version. And select the latest release. So I'm selecting 2.3.22 and then select. So the coordinates should get automatically input here. And now we can click on install. So in the future, if this connector does have a later runtime version, then you can create a compute with that runtime version and select that library. But as of the time of recording, my cluster runtime is 2.12, and I'll select this specific Azure connector. Okay. So now that the cluster is installing, I'm going to wait for it to complete. And once that's finished, we'll be ready to start processing the streaming data in our Databricks platform. Now, as a note of caution, please make sure that you terminate your cluster when you're not using it anymore to avoid costs. You can terminate the cluster by clicking on this stop icon here, and you can also start it again by clicking in this area again. You can access resources for this demo via my GitHub repository called Real-Time Streaming with Azure Databricks. I'll share the link in the resources of this video. So you should see a data.txt file. This simply contains the JSON data structure that I'm using to generate data in Event Hubs. You can copy and paste this for convenience. I also have a file here called Real-Time Data Processing with Azure Databricks and Event Hubs.ipynb. So click on it, and this should essentially be the Databricks notebook that we'll be using, as you can see. So copy the URL, and then on the Databricks workspace, under Workspace, you can import the notebook in a path of your choice. So I'll just go to my user folder, and then click on the three dots, import, and then paste in the URL. Now, as you can see, I have the notebook available in my Databricks workspace. This notebook contains all of the code that we'll be using to process the data and store it in our Databricks Lakehouse. So the initial text box here contains everything we've discussed so far around the solution architecture, the Azure services required, and the specific Azure Databricks configuration. So as you can see right now, with regards to the compute cluster, I specified 12.2 LTS. And for the Maven library coordinates, these are the coordinates that we installed. But I will keep this notebook updated if there are later versions, so please refer to this for the specific cluster and library configuration. Okay, so now let's start streaming data from Event Hubs into our Databricks Lakehouse using Spark Structured Streaming. To start with, please make sure your cluster is up and running. So as you can see, my cluster is running. It's also attached to my notebook. So first of all, I'm going to import the relevant PySpark libraries that we'll be using later on. So this will be pyspark.sql.functions and pyspark.sql.types. And now, what we're doing in this cell is creating our various objects, specifically catalogs and schemas, to implement the Medallion architecture. So these are essentially create statements embedded within the try and accept statements. This first one here creates a catalog called streaming. The second one creates a schema called bronze in the streaming catalog, and then a schema called silver, and then a schema called gold. If the objects already exist, then the accept block will just print a statement. So this just avoids any errors if the objects already exist. So before I run this code, on my Catalog Explorer, notice there is no specific catalog called streaming yet. So let me run this cell. Okay, So now, when I refresh the Catalog Explorer, you can see we have a streaming catalog with bronze, silver, and gold schemas. Right now, they're all empty. And this is essentially how we'll store the data. The bronze schema will store data in its raw form. The silver schema will store processed data. And the gold schema, refined and aggregated data. So now, navigating back to the Databricks notebook, the cell block a bit further below, here, initiates the stream. So this specific code initiates the stream. And then this code here writes the stream to a table called weather in the bronze schema. So we first use this read stream method, which is part of the Spark Structured Streaming API, to read in the data from the Event Hub service. And the format of that data is Event Hubs. And then we also use specific configuration dictionary and pass that into this options method here. So here are the configuration details. So this dictionary is essentially what we pass in here. So we have the following. We have the connection string. So I'll need to paste this in. But essentially this variable holds the connection information for the Azure Event Hub. This is specifically the shared access key which we'll create from Azure Event Hubs and paste it in just a moment. We also have the Event Hub name. This is just the name of our Event Hub. And then here we have the configuration in a Python dictionary. It contains the configuration for the Event Hubs connection. So notice this eventhubs.connection string. This key is set to the encrypted version of this connection string you pass in. This encryption is done using the Event Hubs util.encrypt method for the Spark connector that we installed on this cluster library. We also have eventhubs.eventName, which is just the Event Hub name that we provided. Okay, so to give access to our Event Hub, we'll need to generate a shared access key. So in the Event Hubs service, make sure you're in your Event Hub and click on Shared Access Policy. Then click on Add. Give the policy a name. So I'll just call it Databricks. We want to give it listen permission. And click on Create. So here is the shared access key. Click into it and copy this connection string here. So connection string, primary key. So now back in the Databricks notebook, paste that in here, inside of double quotes. And now pass in the Event Hub name. For me, that is just eh-demo. So let's run this cell. So now, let me copy this portion of the code into a new cell. I will run this code on its own rather than the write stream as well. So right now here, we're just initiating the stream using the read stream method. And then we're displaying the stream. And as you can see, this contains the configuration options to connect to the Azure Event Hubs. So let me run this. So now the stream is initializing, as you can see. But as yet, nothing will be displayed. And this will be because we haven't generated any new data since the stream was initialized, even though we have previously generated data using this generate data feature. But the reason that data isn't available is because this stream is live and it is only accepting data while the stream is open. It is not processing historical data in our Event Hubs. So in Event Hubs, let me generate some more data. So I will continue to use a user-defined payload. The content type will be JSON, and I will paste in this JSON object again, and click on Send. So that has been sent. So if I go back to my notebook, let's wait a moment and see what happens. So as you can see, here is the event. We have the body column, the partition, the offset, the sequence number, the enqueued time, and all of these various metadata columns as well. Now, notice this body column contains the message, but the message itself is in some strange binary format. We need to actually convert this into a string to be able to read it. And then we need to convert that string into a JSON object in order to be able to process it. But for now, notice how the event has been processed. We've got a single row here. So if I restart this stream by rerunning the cell, let's see what happens. So I will just rerun this cell again. And note, you can also stop the stream by clicking on interrupt. This will stop all running cells in the notebook, and then you can just start the stream again by running this cell. But if you do click on interrupt, then that will stop all running streams in your notebook. So now notice, the data that we just generated has gone. That single record that we generated here is not displayed in this stream anymore. This is because the data does not persist in our Databricks environment. So using this read stream method, the data is not stored in any permanent storage. It's just temporary. Data will build up in this stream while the stream is active. But once you terminate the stream, then the data is gone. So to persist the data, we need to write it to storage. And we do this using this write stream method, as you can see here. So on the streaming data frame, which I've called df, we use the write stream method. We're required to specify a checkpoint location. This checkpoint location is used to store the state and progress of a streaming job. It ensures fault tolerance, and it enables the job to restart from the last processed point in case of failure. So the checkpoint location I've set here is mnt/streaming/bronze/weather. So this is in our Databricks file system. You can access the Databricks file system in your Catalog Explorer by clicking here on Browse DBFS. If you don't see Browse DBFS, click on this drop-down under your username, click on Admin Settings, Workspace Settings, search for DBFS, and ensure DBFS File Browser under Advanced is enabled. As you can see, it's enabled for me. You'll then have to refresh, and then when you go to Catalog, you should see this Browse DBFS button. So click on it. When I run that cell, I should see a folder called MNT. MNT is short for mount. And when I initiate the stream, that folder will be created here along with the subfolders. And then that will contain the checkpointing information. So now the output mode in this write stream method is append. This means that new data is appended to the stream. You can see the different output modes on the screen for your reference. Now finally, we're writing the data into a delta table. So the format specified is delta. And the path to the table is the streaming catalog dot the bronze schema dot a table called weather. So that is where it will get saved. So let's terminate this stream by clicking on interrupt. So that has been cancelled. Now let's run this. So this will read the stream, it will display the stream, and it will write the stream and persist it in a table called weather in the bronze schema of the streaming catalog. So let me click here. So the stream should soon initialize. Great. So right now, nothing is displayed because the stream is empty. So let me generate some data again. So I will generate this same data and send it. So now, in a moment, you should see the data here. As you can see, the event has been loaded. So now, let me send another event. So this time I will modify this slightly from 20 to 22, and then send. So that has been sent. So now let's wait a moment, and that should get processed here as well. As you can see, we have 2 rows, so I can expand this, and we have 2 events. So if I go to Catalog Explorer, here is the streaming catalog, here's the bronze schema, and here's the table. So I can click on the table and view some sample data. So as you can see, the data has persisted. I can also query it on the notebook using an SQL cell. So I will just do select star from streaming dot bronze dot weather. And as you can see, here are the results. So this now persists. Even if I terminate this stream, this data has been stored. Now, if I go to the Databricks file system on Catalog Explorer, as you can see, here's the mount path. And here is the path to the checkpointing information. So here is the checkpoint information. So that is where the checkpointing information has been stored. This is what keeps track of the state and progress of the stream. Okay, so let me generate another event in Event Hubs. This time I'll change the temperature to 32 degrees. I'll change the humidity to 40. I'll change the wind speed, the wind direction, and I'll keep the rest the same and generate this event. So now, back in my notebook, you should soon see an additional row will get added to this stream. As you can see, we get 3 rows. Here is the third event. So now, if I query the table again, we also get the additional record. So far, we've read in the stream, we've displayed the stream, and we have written the stream to a table called weather in our bronze schema. Now, as a note, if you decide to take any breaks, then please make sure you terminate your stream by clicking on interrupt, and manually shut down your cluster by going on your compute and clicking on this stop button here. If you keep your stream active, your cluster will continue running indefinitely and you'll keep incurring costs. So please do make sure you terminate your cluster manually and stop your streaming queries. Now I'll talk you through the code used to process the data into the silver layer of the Medallion architecture. If you turned off your cluster and stopped the previous stream, then please make sure you turn your cluster on again and rerun the previous cells. So rerun the cells where we've installed these libraries, created the connection string and the configuration, and initiated the stream here. So as you can see, I've got the stream running where I'm reading it from Event Hubs and I'm writing it to this bronze table called weather. So in the silver layer, I'm going to skip over this bit for the time being where I'm defining the schema for a JSON object. In the cell below, I'm reading in data from the bronze table using the read stream method. So essentially, I'm initiating a stream, but rather than from Event Hubs, I'm streaming from this table here. And then after that, I'm performing some transformations. I use the with column method to reference this body column and cast it as a string. Because remember previously, it displays the values in this binary format. So I'm casting it as a string. So let me actually show you how this looks on a static data frame. So I will create a new cell here, and I'll read in the bronze weather table into a data frame. But I won't use the read stream method, I will just use spark.read.table. And I will read in the streaming.bronze.weather table. I'll just assign it into this temp_df variable, and then I will display that. So this is what it looks like right now. This is in binary format. So to convert this from binary to string, all I need to do is use the cast method. So I will add with column, and I will call that column body, and I'll also reference the body column. So col/body dot cast, and I'm casting it as a string. So let's run this. So now, as you can see, we can now actually read the contents of this body column. This is because it's actually stored in string, so it's now human readable. Now the next transformation would be to actually make this tabular. So for instance, you'd have a column called temperature, humidity, wind speed, wind direction, precipitation, and conditions, and they would store all of these data values. So temperature would contain 32, 20, and 22, and so on. So we can convert this string here into a JSON object using the from_JSON method, which is what I've done here. From JSON. So the first argument in the from JSON method would be to specify the column and then the schema of that column. So in this cell here, which I skimmed over previously, this is the schema for this JSON format here. So let me run this cell, and it's stored in this variable, JSON schema. So now I can convert the string into a JSON object using this additional method. So let me just copy this and paste it here. So let me just add this in a new line. And run this. So this has been converted into a JSON object. It doesn't look much different, but as you can see, it says object here now. So this is no longer a string. So the significance of this is now we can select specific keys and display them as columns. So let me show you. So what I can do is type dot select, and now let me select some columns from this JSON object. So I will select this temperature column. So I can do that using dot notation. So if I type body dot temperature, this should return this column in tabular format. And I'll select some others as well. So I'll select body dot humidity as well. And then I'll also select this enqueued time column. So let me copy this and pass that in as well and run this. So as you can see, we've now converted this into a tabular format. So essentially we've parsed the JSON data and displayed it in tabular form. So if I actually copy this entire thing and paste that here, we've performed all of the transformations, and in this select method, I've selected all of the columns within the JSON object using dot notation. So we've got temperature, humidity, wind speed, wind direction, precipitation, conditions. And then I've also selected the enqueued time column, but I've aliased that as timestamp. So if I run this, and actually I will not make this a stream, I will just make this read. I need to actually store that under temp_df and run this. As you can see, this is what the output looks like so far. So now, if I explain what's going on with the code block below, I use the readStream method, perform all of the relevant transformations to display the JSON object in tabular form. I alias enqueued time as timestamp. I display the stream, and then I write the stream by specifying the checkpoint location. So this time the checkpoint location is slightly different. It's going to another subdirectory called silver and then weather. The output mode is append, and then I specify the format as delta, and I'm streaming it to a table in the silver layer this time called weather. And just to elaborate on the use of checkpointing, because this is a different stream, I'm using a different checkpoint. So now let me run this cell and initialize the stream. Okay, so the stream has initialized. So let's wait a moment. So as you can see, the stream has immediately processed 3 rows. This is because from our previous stream, as you can see here, we already have 3 rows. So this has read the stream from this bronze table and it has processed it onto the silver table. Unlike with the first stream, which will be empty if I restart it, so if I restart this stream now, it will be empty. As you can see, nothing is present. If I restart this stream, it won't be empty. It will still process the historical records. Let me show you. As you can see, this is because we are reading this stream from a table rather than from Event Hubs. So this delta table contains pre-existing data, whereas in this previous query, because we're reading the stream from Event Hubs, we're only able to capture data while this stream is open. Great. So now let me generate some new data and show you how data flows through the bronze and the silver layers. So I'll go to my Azure Event Hubs instance, and I will modify this from 32 to, let's say, 18, and send this. So now back in my Databricks notebook, I'll delete this cell because we no longer need it. Notice here, we should see a single record displayed momentarily. And we do. That is the event that I just generated. And now further down, we should see a 4th row. And we do, where the temperature is 18. So this has been processed. So to summarize, we capture the data from this read stream method into this weather table in the bronze layer of our Medallion architecture. And then in the silver layer, we read the data from the bronze table, process it, convert the binary column into a string and then a JSON, and perform the relevant column aliasing, and then write that into a stream in our silver table. And now this should persist in the silver table. And you can also query it just to test it. So select star from streaming.silver.weather. So let me run this. So as you can see, the data has persisted. So now the final part of the Medallion architecture is to further refine and store the data in the gold layer. For the gold layer, I want to aggregate the data in 5-minute intervals using the timestamp column. So we get the average temperature, humidity, wind speed, and precipitation in 5-minute intervals. And you can see the code here. So I read the data using the read stream method from the silver delta table. Ignore this watermark for now, and I'll come back to that. I use this group by method and specify a window function on the timestamp column. Remember, this timestamp column is the enqueued time column that we aliased. The window function is a special type of grouping function used specifically for time-based data. It creates a time frame over which data will be grouped. So based on this syntax, it means we group the data in 5-minute intervals using that timestamp column. I then perform some aggregations. So essentially, I get the average temperature, the average humidity, wind speed, and precipitation. So going back to the with watermark method, this tells you how long to keep each window open. I've specified 5 minutes. What that means is that Spark will wait to close and output the windowed aggregation once the maximum event time seen minus the specified watermark of 5 minutes is greater than the upper bound of the window. This diagram explains it well. So in this example, we have a 10-minute tumbling window trigger. So every 10 minutes, the aggregation gets calculated. The watermark is 10 minutes as well. Notice the row highlighted in green in the top with an event time of 10:53. This actually arrives late at 11:03. However, it's not omitted from the 10:50 to 11 a.m. window. So let me break down what happens and focus on the 10:50 to 11 a.m. window. The watermark is calculated relative to the maximum event time seen by the system before it can close the window. So for the 11 a.m. tumbling window trigger, the latest event time to date is 10:56. Subtract 10 from this and we get 10:46. So we cannot close the 10:50 to 11 a.m. window yet because 10:46 is not greater than 11 a.m., which is the upper bound of the window. Now during the 11:10 a.m. tumbling window trigger, the latest event time is 11:02. Although this is later than the 10:50 to 11 a.m. window, we still cannot close the window because 10 subtracted from 11:02 is 10:52, and 10:52 is still not greater than 11 a.m. Since the window is still open, the event highlighted in green, which is the late coming event with the time of 10:53, gets included in the 10:50 to 11 a.m. window. So let me explain when the 10:50 to 11 a.m. window actually closes. During the 11:20 tumbling window trigger, we have the latest event time to date of 11:15. If we subtract 10, we get 11:05. So now finally, this is later than 11 a.m. Hence the 10:50 to 11 a.m. window can close. This is why in the output at 11:20 a.m., we get the results for the 10:50 to 11 a.m. window. And note, even the event with the event time of 11:12, which arrives at 11:15, would also have closed the window. So to emphasize, the watermark delay is relative to the maximum event time seen by the system and not the wall clock time. So any data coming after the watermark interval will be dropped and not included in the windowed aggregations. This helps manage the state size and ensures that aggregations eventually complete even if some data is late. I'll share a blog post that explains watermarking in detail in the description of this video. Okay, so now that I've explained how we're reading the stream, I then write the stream into a gold table called weather summary. I use the output mode as append, and I've also specified a separate checkpoint location in the same mnt/streaming path, but this time it goes into its own weather summary folder. And actually I should probably add /gold here, like so. Okay, so let me begin the stream, but I won't perform the write stream operation yet. I'll just run the first half of this code, specifically the read stream part. So let me copy this into a new cell. Notice this final line using the select method. I'll ignore that for now and comment it out. So let's run this. So the stream has initialized. And we'll see the results so far. Great. So here are the 3 records that we processed previously. Notice the window. So we have a start and an end, and this is in JSON format. So this is a window at 3 o'clock, and then the window ends at 3:05. Here's a window at 2:40, and that window ends at 2:45. Similarly, another window at 2:45 to 2:50. So if I add more data, then it should get processed into another window. So let me do that. I'll go back to my Azure Event Hubs. I will change this to, let's say, 28. I'll change this to sunny and send. So now, going back, we should see, first, in the bronze layer, the data should get added on this stream and written to this bronze layer. And here's the record. Now in the silver layer, we should be reading it from this bronze table and writing it to the silver table. So you should see it in a moment. 28 degrees, here it is, sunny. And now in our aggregated table, we should see another one with this specific timestamp. So let me actually show you here. Here it is, 28 degrees. It is in this window from 3:10 to 3:15. This is the current window. So now let me process another event and see what happens. So I will make this 18 degrees and send. So now let's just wait a moment for this to refresh. Great. So here is the new data, 18 degrees. We've now entered a new window because I sent the event after the window close time for the previous window. So if I actually do another event now, and I'll make it quite obvious, I will make it 1018, so it's a large difference. And now what we should see is this window is still open. So this temperature should now change to be the average temperature of the two records. So this will change from 18 to something else. So let's wait. As you can see, this is now the average temperature. So this is the average of 18 and 1018. So it is now 518. Great. So now as a final thing, notice that this window column is a JSON object. So we can actually extract the start and end times in their own separate columns. And that's what this commented line below does. I select the start column using dot notation, the end column, and the other columns as well. So if I actually run this, notice the format. So we actually have the start time and the end time, and we can actually just sort it now. So it's in order. So this is the earliest to the latest event. So let me actually delete this cell and run this cell where we're reading the stream, displaying the stream, and then writing the stream to the gold layer. So this will write it to a table called weather summary. Great. So here are the 5 rows. So let's query the table. And as you can see, we return 3 rows rather than 5 rows. This is because we have still not closed these 2 windows. So this window is open and this window is open. So the windows will close 5 minutes after the window end time. So this window should be due to close soon because it's almost 3:20. And when it does, that is when it will get written to the table. So only the closed windows will be written via this write stream method. And that is because of the settings in this with watermark column. Great. So we've now implemented the Medallion architecture that reads in streaming data from Event Hubs, and then it writes it to the bronze layer. It then reads it from the bronze layer, performs some transformations, and writes it to the silver layer. It then reads it from the silver layer, performs some refinement and aggregation, and then writes it to the gold layer. Okay, so now, as the final part of this project, I'll make the data available in Power BI via direct query, so we can get near real-time information available for reporting. To make the data available in Power BI, we can use Databricks Partner Connect. So scroll all the way down to Partner Connect. You can either search for Power BI or you can locate it here. So I'll click on Power BI. Select your compute cluster. For me, it's this one. It's not the SQL endpoint, it is the interactive cluster. And then download the connection file. So this connection file should be in your downloads folder. Once you open this, it will open Power BI Desktop. For this part of the project, you will need to be using a Windows operating system. So I'll switch over to that. Great. So I'm now on a Windows operating system. So if I go to Downloads, here is the file that I downloaded via Partner Connect. So let me open it. This will open up Power BI Desktop. So it then should present this dialog box. So you can sign in using Azure Active Directory. It should then open up a dialog box that contains all of the catalogs in your Databricks Unity Catalog Metastore. So here is the streaming catalog, and here is the bronze, silver, and gold layer with all of the tables that I've created. You can select as many tables as you like. Typically, the gold layer tables should be refined for BI tools, but I'll pick the silver layer table because this is easier to demo. The gold layer table, as you know, has a watermark, so it will take longer to reflect changes in the report. So I'll select silver and then click on load. So notice the storage mode is direct query, as you can see from the bottom here. With direct query, no data is imported into the Power BI store. Instead, when you build a visual, Power BI Desktop sends queries to Databricks to retrieve the necessary data. The time it takes to refresh the visuals depends on the performance of our Databricks compute cluster. So direct query relies on the compute cluster that I specified during the Partner Connect setup in order to retrieve the data. So for this reason, every time I open this Power BI report, it will start up our Databricks compute cluster. So if you're following along, once you're done with Power BI Desktop, please delete this report or change it from direct query to import mode by clicking here and then switching all tables to import. So let me create a simple table visual. So I'll select this table and I will just pick all of the columns in this weather table. Timestamp, conditions, humidity, precipitation, temperature, wind direction, wind speed. So I'll let that all refresh. So all of the columns have been selected. So as you can see, this is all of the data that we've processed to date. So now, back in Azure Event Hubs, I'll add another event. So on generate data, I will change the temperature to something more reasonable. So let's say 10 degrees. And I'll lower the humidity and increase the wind speed. And I'll change the wind direction to northwest. And the conditions as cloudy. So let's send this. So what will happen is this will get processed in our Databricks notebook through all of our layers. So this silver layer table should contain the additional record. And indeed, it does, cloudy. Back in Power BI, this additional event should be added soon. However, the visuals in direct query refresh every 15 minutes. And since I don't want to wait around for 15 minutes, I'll just manually perform a refresh and we should see this record. So as you can see, we've got an additional record and here it is. This is the current timestamp for me, 3:33. And the conditions are cloudy, as I specified in the event. Great. So now I'm done with this Power BI report. I'll delete it. So back over in Databricks, please make sure you terminate your streams by clicking interrupt. And also, shut down your cluster manually to ensure you do not incur any additional charges. So that was the end of the project. Thank you for following along with this comprehensive tutorial on setting up an end-to-end real-time analytics solution using Azure Databricks Event Hubs, and Power BI. Throughout this series, we've journeyed from the initial setup of Azure Databricks and Event Hubs, implementation of the Medallion Architecture, ingesting and processing large-scale data streams, and leveraging direct query in Power BI for real-time insights. Remember, the resources, including the Databricks notebook, are available on my GitHub repository, which is provided in the video description. Also, don't forget to check out the additional links for a deeper dive into concepts like watermarking. If you found this series helpful, then please like, share, and subscribe for more content on cloud analytics and data engineering.